Okay, Assalamualaikum and good evening. So, boleh nampak saya punya screen, share screen right now?
Boleh Dr.
Nampak.
Okay, so basically, we're going to continue our topic on the suspension. Okay, yesterday we already learned about mainly on the function of the suspension system, and then we also take a look at the types of suspension system, types of passive suspension system. So basically, there are three types. We have rigid, semi-rigid, and independent suspension system. So basically, for the rigid suspension, we typically use in pickup, commercial vehicles. Okay, and then for semi-rigid, referring to the type of suspension that typically used for rear suspension for passenger vehicle, which is the most common one that we can see is that the torsional beam. And then the most famous suspension system type for the third one is independent suspension system, which is we have the most common that being commercialized in passenger, which is the McPherson strut. Other than that, we also have the SLA type and multi-link axle. Okay, for the SLA type, SLA stand for the this one SLA. The SLA is mean that short, long arm suspension. Okay, and then we have a short, long arm suspension system. So usually for this one, double wishbone also famous in the continental car like Mercedes, BMW, and also the US car. Okay, and then in our country, the most common suspension is the McPherson axle, and then for the multi-link, Japanese car, most of them have been using the multi-link suspension. You need to remember, even though that let's say for example for Honda, so even though that we have the same Nissan GTR in Japan, Nissan GTR they don't build it in Malaysia. For example, the apa okay, let's say that for vehicle model that being sold in Japan and vehicle model that being sold in Malaysia, even though then sometimes that the vehicle look the same, underneath the vehicle usually they're going to have different specifications. So that's why you seeing that people prefer to have the Japan spec, okay, because the specification based on the region is not the same. Because in Japan they can have, for example, like this multi-link, because the Japan consumer can pay higher price for this type for higher specification for the car model, but not in Malaysia. For in Malaysia, for that price, people will not buy it. Okay, so sometimes they're going to revise the specification for the car. I think in general, not only at looking at the suspension type. In general, they're going to revise the specification and use the most common specification for Malaysian market, which is kalau nak tengok apa, suspension, McPherson, for front, torsional at the rear, and then for engine, sometimes in Japan they might have the turbo, but not in for Malaysian market. Okay, usually usually if you are seeing the same model being sold in different regions, sometimes the specification are not the same, because they usually the OEM or the manufacturers, they're going to revise the specification according to the end users capability to buy that model. Okay, saya nak ada yang masuk. Okay, part this one, Okay, this is actually the example for the rear axle for trailing arm. This one is actually referring to the apa semi rigid as yeah, semi rigid. So this is just an example. So this one is actually semi rigid suspension, which is trailing arm. Okay, you need to remember the rigid and semi-rigid. Usually, there's going to have the what the connecting rod between the left and right side of the tire. Okay, ini semi-rigid suspension because of this one. Okay, so this one. This is actually example for yeah, Audi A6. Usually for front, they've been using this one is for yeah, for multi-link suspension for front yang depan sorry ini depan ke belakang yeah. This one is oh yeah, front. This one is front side because we can see that this is the steering. Okay, so this one is a multi-link. Okay, ini front, this one is rear. Okay, this one is a multi-link. This one using the apa ini macam also multi-link. Okay, you need to remember because sometimes for multi-link for apa high-end car Japan apa continental car BMW Mercedes, sometimes they don't use a common suspension configuration like the apa kita punya like Mahan lah. Usually if they for us if we use apa McPherson start for the front suspension, we might be using the common trailing suspension at the back. Okay, that's for what common price vehicle. But for high end vehicle, if they can have multi-link at the front and also they can have multi-link at the rear. They're not necessarily they're going to use multi-link at the front and then they're going to use semi-trailing at the rear. No, because usually for high end they're going to look or if they're going to prefer to have a better handling at very high speed, which is multi-link is what it is a type of suspension that is known to provide this kind of performance in terms of handling performance. Okay. Okay, ni example for Audi TT. Okay, for Audi TT, this one is front ni McPherson strut. Okay, ini this one is independent. Sama lah depan McPherson. This one kalau yang belakang, okay, this one is using apa semi-trailing. So why I know the semi-trailing because I can see that this is the what the suspension sorry the spring seat and this is the shock absorber. Okay, same configuration like the what torsional beam apa semi rigid suspension. Okay, like the one that we have in Myvi, Prodor Myvi, Azia. Okay, but this one being tuned lah for to meet the or to meet the handling target for this vehicle because Audi TT this one is a high performance car. McPherson, so this one is a semi trailing. Torsional beam. Okay, this Audi A8 the multi-link rear axle yang tadi lah. So if you take a look at here, we have a lot of link. This one referring to the first picture of Audi A8, but this one referring to the rear axle, where you can see that there is what this is the spring for the rear axle. Okay, this is the spring. This is the shock absorber. Spring. This one is a shock absorber. Okay, and then they have this kind of link. Okay, what why it's been called as a link, multi-link, because the one, because it has more than, I think more than two of linkages, because typical for for McPherson strike, for this one, take a look at this one. Okay, McPherson. So we only have the what we call as a drop link. Okay, yang kalau yang kat sini, yang kat ini, this one is actually drop link connected to the RC roll bar. That's the only link. Okay, yang other than that is just arm, and then the knuckle at here, and then the that's it. And then the shock absorber strap being attached here to this position. But for the multi-link, it's going to have more than two, which is this one, ada yang ni, bahagian sini, okay. And then this one, multi-link, okay. And then yeah, we have this one, multi-link, okay. So we have more than two link in multi-link. So that's why it's being called multi-link. Okay, and then this kind of suspension in terms of performance, like I mentioned previously for so many times, being proven to have a good handling lah. So yeah, yeah, I think the most no, for common vehicle we don't use multi-link. The closest one is BMW, Mercedes, and this one is Audi Continental car. Okay. Okay, now we're going, before we go to the directional behavior for handling, for how the suspension and the steering system should be expected to provide a good handling to the vehicle. So I'm going to take a look at again on the advanced suspension. So right now we are looking at the type of suspension for the passive suspension. Like I told you previously, I think in the introduction in early class, we already take a look on the a group of advanced suspension system, which is on the semi-active and active suspension. But the one is just a brief of it. So tonight I'm going to go into detail, a little bit detail. So basically, suspension type we have passive, uh, so basically we have passive, and then we have advanced suspension. Okay, and then for passive suspension system, mainly we have the spring and damper lah, the main element. Spring and damper. And for this passive suspension, like we just learned, we have it can be further divided into three types of suspension, which is the rigid, we have semi-rigid, and then we have the independent suspension. Okay, with the rigid, we can see it as okay in rigid suspension, the one that we typically see in a commercial vehicle, in truck, pickup, and then for semi-rigid we have a torsional beam, and then independent is for most common one we have the McPherson strut. Okay, and then other than that we have for independent we have the multi-link and the multi-link and SLA type suspension system, short long arm suspension. Okay, and then for the advanced suspension can further divide into okay for semi-active, and then we have active suspension. Okay, And then for semi-active, usually, for semi-active, you have two type lah. Okay, the damper for semi-active, same thing. It's just that for semi-active, we have spring and variable damping damper. Spring plus variable damping damper. With this variable damping damper, we can have means that for when I say that variable damping damper, that it does not use the common damping or shock absorber. It use the shock absorber, which the characteristic of the damping coefficient can change depending on the condition of the road profiles, and then this value is actually being controlled by the electronic system, by the sensors. And okay, and then this variable damping damper, we have two types. We have a variable orifice. Second one, we have MR damper. Okay, this MR damper stands for magnetorheological damper. Magneto is long name actually. Magneto. Okay, this MR stands for magnetorheological damper. Okay. Okay, in variable orifice, the way that it works is that in shock absorber we have a fluid, and then usually this fluid, when we compress, it will be pushed to go through a small opening, or what we call as orifice. That one is in the in a normal or conventional shock absorber, but in variable orifice damper or shock absorber, this opening or orifice is actually can be closed and open depending on the operation of the solenoid valve. And then these openings actually being controlled by the electronic system. Okay, meaning that if the openings being closed a little bit, so meaning that close to the fully closed position, so meaning that that fluid is actually going to be have a harder time to go through the opening. Okay, kalau if the orifice being open, the solenoid is being actuated, so it will be fully open. So meaning that the fluid will have easy access to the opening. So meaning that we're going to have a slow we're going to have a low damping coefficient. So that's the for the variable orifice damper. And then for MR damper, it's actually using the what we call as the magnetoreological fluid, and this fluid is actually comprising iron particles that being mixed together with carrier fluid, typically oil. And then how this fluid being manipulated is that whenever it's being exposed to the magnetic field at the orifice, so this fluid is going to harden, okay, and then clog the flow of the MR fluid. So when the flow being clogged or being when the flow being restricted, so meaning that we're going to have high damping coefficient for that shock absorber. And the switching between the magnetic field on, off, and off is going to create the condition of high damping coefficient, low damping coefficient, and then keep on switching depending on the condition of the group profile. And this thing is actually being controlled by the electronic system. With the control system is the one that already demonstrated to you in class. So how this type of advanced suspension could improve the vertical motion of the vehicle. So meaning that if you driving on the on rough road, so only your unsprung mass going to move excessively with the your chassis will try to maintain its position as level as possible. Okay, so that one for the semi-active suspension. And then next we're talking about active. So in active we have what we call as a slow active, and then we have fully active. Okay, in slow active meaning that we still have the apa spring shock absorber, and then with it comes this actuator in slow active, where this actuator function is just to correct the tilting or rolling motion during cornering. So meaning that if the sensor sense that your chassis like there's a rolling, so you're going to this usually they going to use the electrical motor to lift up the vehicle. If this it sense the what the level is low, it's going to lift up, and if it sense that the level of chassis is high, it's going to pull down. Okay, that's the function of the actuator in the slow active suspension. The shock absorption still being done by the spring and the damper or shock absorber for the vehicle. Okay, of example of car that been using this one is usually for Mercedes-Benz. Most of the high-end Mercedes-Benz using this type of suspension. And then next one we have the fully active suspension, where in fully active suspension we don't have a spring and damper. We only have apa electro we only have linear electrical motor, which that is the only element that going to do the shock absorption as well as to do the chassis leveling. Okay, so one actuator do two functions at the same time based on the function. And usually, this type of suspension system is very expensive. And then I think I already shown or shared with you the Boss suspension system. And then this Boss suspension system, even though that is being introduced in I think in 90s as a prototype, until now is not being famously being commercialized among the OEM because of the cost is very expensive, and then the maintenance also very tedious to take care of it, because if the system fails, then that's it will not work. Okay, compared to the semi-active suspension, where in semi-active suspension using the especially for MR damper, if the magnetic actuation system fails, this shock absorber still going to operate in as if it's a passive shock absorber. We still have that characteristic. Okay. Okay. Any questions regarding this suspension type for both passive and advanced for an advanced suspension system? Any question? Any question?
No, doctor.
Okay. Okay, now we're going to okay. Okay, now we're going to take a look at the demand for directional behavior. This one should include. This one is actually for the apa, steering system. No, this one I'm going to skip for now. I'm going to come back. This one ignore this slide. I think it's mana boleh start sini. Okay, now we're going to take a look at the terms for suspension. You need the most basic term for referring to the kingpin offset, and then we have the toe in, okay, toe in, and also the camber, okay. 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 Now this is the for the kingpin. So okay, kingpin. So usually kingpin is offset or steering offset at the ground. It's like a scope radius between wheel center and the point where the steering axis intersect the road surface. So this is the kingpin offset. So positive point of the intersection of inside point of intersection is inside of a wheel center inside track as illustrated. Okay, this one is we have the positive kimping off offset. So you're going to affect the steering system to longitudinal forces, and then okay. So for the deflection force level arm or RST, this one the shortest distance between the wheel center and the steering axis. So to effect, you're going to effect the driving forces of on the steering system. Okay, next one is the toe in or toe angle. So usually when you go to the to do or to service your tire, usually we call this one as a wheel alignment. and in wheel alignment. So basically what we did is that we're going to adjust how the wheel ini daripada okay, top view. Okay, top view. So kalau macam okay, toe in ini from the tire tu dekat top view. Okay, ini tire lah. Okay, daripada yeah, ini one wheel. So basically kalau distance of CB C is less than D, distance of the lower part of the wheel. So this one we call as a toe in. So kalau ini dia kalau macam keluar arah sini, C distance C lagi besar daripada distance B. Okay, like this one. So we're going to have a toe out, and in fact it's going to compensate the kinematic forces due to lateral forces acting on the tire, and usually the toe in going to affect your ability to take corner. Okay, kalau macam and then also going to affect the tire wear and tear. Okay, usually for vehicle we're going to have a slight toe out. Okay, toe out like this one. And then whenever during when we lift up the wheel, the mechanic going to do the setting for like this one. So whenever we put back the car on the ground, it's going to do this due to the weight, it's going to correct itself like this one. Okay. Okay, we're going to correct. So by this, when doing this one, we're going to minimize the angle of tilting, even though that we need that tilt angle. Okay, it's just that we don't need it to be done excessively because it's going to affect the tire wear and tear. Whereas too much our toe out is going to shorten the life of the tire. Okay, so this is the common setting for passenger vehicle, but toe in usually we use toe in being used to increase the apa uh, uh, tire track width, because if you have a wider tire track width, meaning that we're going to have or increase the stability of the vehicle. Okay, so okay, and then ini daripada ini, and then another one is that we have the camber angle, where in camber angle ini ada slide betul. Okay, for camber angle we have a positive and okay, toe in and toe out. I think this one is a from view. Okay. Okay, let me check. This one is, this figure is actually belong to the camber angle. Well, okay, macam saya silap letak dia punya figure. This one belong to the camber angle. Toe in, okay, tak ada. Saya betulkan. This one belong to the camber angle. Okay, I'm going to update the figure in the slide later on when I reshare again the slide. So basically, this is the okay. You need to remember the most two term that apa that is required when you need to do the wheel alignment. The first one is the toe angle. The second one is the camber angle. The typical wheel alignment of tire service that we do is usually we're going to do the toe angle adjustment. Then this one being done by machine. Okay. Okay. Usually, okay, same thing, toe in, toe out, and then you're going to effect the lateral forces and see how it looks like. And then usually for vehicle, we try to have the apa uh, uh, um, uh, toe toe in, okay, toe in a little bit because this and then for toe out usually we use for apa macam racing car because it give you a wider track width, okay, contact one. And then for this one is actually for camber angle. Okay, so we have a negative and positive, and then for this camber angle, it's going to affect your track width of the vehicle. And then usually for passenger vehicle, we have front camber angle and rear camber angle. And then for camber angle, we tend to have a negative setting for the camber angle about 1 degree. Okay, 1 degree, 1 degree, 1 degree, negative. Okay. Some of the workshop they tend to have to do the setting of apa zero angle for both toe in and toe out. Okay, that one is what we call as a neutral toe and or neutral camber. Okay, they just try to play safe, but in terms of for setting, yeah, this play safe. But in terms of performance, if you want, let's say, if you want to have a slight wider of your tire contact in terms of track width, you should have the negative. So that's why if you take a look at the you go to service or do your wheel alignment for front. Apa for front, if you want to adjust your camber angle usually within 1 degree lah, no more than that, because if not your wheels looks macam apa macam ni lah tu apa orang panggil in bahasa Malaysia macam apa terbuka terkengkang sikit lah. Okay, ini effective camber apa negative camber angle. It just the purpose is just to increase the track width. In terms of performance, baguslah. But the bad thing is that it's going to wear your tire very fast, and then also it's going to to ruin your fender, your apa wheel housing. Okay, when there's some modification been done, usually yeah, in terms of performance it's good, but in terms of apa aesthetic appearance, it look a bit weird, and also it can ruin your fender because this wheel it need to move up and down. So when you change this one, usually it going to the upper part of the wheel going to hit the apa dia punya wheel arc yang kat atas ni. So that's why if you take a look at most of the modified car for this excessive negative camber, so you can see that the arc over here is actually apa damage lah because the movement of the wheel up and down movement is actually colliding with the wheel arc. Okay. And then that one for front camber adjustment. And then for the rear camber adjustment, usually we don't do the adjustment for the rear for the rear axle. Okay. And then for rear axle, usually if you want to do increase the camber angle for the purpose of increasing the track width, you can also still can do that, but you need to change your apa dia punya lower arm. Okay, you need to use a adjustable lower arm. For that one is the aftermarket part, and for OEM usually it will be fixed. The camber angle will be fixed, no matter how. Let's say that they did the tuning for the camber angle for rear axle is wrong because there is, for example, Proton Pave, they are having a bad configuration for the camber angle. So based on the user user comment or complaint, the rear tire tends to wear very fast. Okay, rear tire. So it turns out when the person check this one, they have actually put excessively determine the camber angle for the rear axle for the parade. Okay, so they did the apa the correction, the what they correct the issues. So new, I think, yeah, this one private, although even though that it already being discontinued, the apa the uh, 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 I think the facelift version already addressed this issue, but the problem is the previous batch of the previous owner suffer from this issue. Okay, including me. So for me, yeah, I already changed the rear lower arm using the adjustable lower arm from the aftermarket part, so I can adjust the camber angle myself, but at the workshop. Okay, but for, yeah, if you don't change using the aftermarket lower arm, adjustable lower arm, then then you cannot do anything because the camber angle is being fixed by the manufacturer. Okay, for front you can adjust it. Uh, there are two types of adjustment for the front. Basically, they're going to adjust the strut at the and the knuckle. Okay, dia ada, kalau macam McPherson strut, kita ada ini. This is our McPherson strut. Okay, ada macam ni. So suspension tower, and then it will go being slot into the uh, knuckle arm. So ni adalah knuckle ni. This is our wheel being slot over here. Usually the this one is front view, and then in terms of this direction side view, usually in the slot okay over here. So the what the mechanic still has the room to adjust the camber based on dia punya gap of tolerance over here. Okay, experienced mechanic, they can do this, but common mechanic, they will advise you to buy this camber nut, which is just a simple bolt. Okay, itu kalau macam yang tak tahu tu, yalah, kena beli jugalah camber bolt apa, camber nut tu for RM30, I think one piece. I think RM30 quite expensive lah, even though it's just a simple bolt and nut. Okay, but if you go to some normal workshop, they don't need do that. Okay, you don't have to actually buy that bolt nut. Okay, tapi itulah depends lah. If you still insist to do on the modification on the camber angle, but that mechanics don't know how to do it manually, then you have to buy that nut for RM150 for one piece. I think that's very expensive. Okay, any questions on this toe angle and camber angle? I will update this slide, okay? Because some the information is kind of a bit mislead because the figure is not correct. Okay, any questions on this one?
So far, okay, doctor.
Okay, now for the roll center. So the roll center is actually where your where your vehicles is roll. In vehicle we have two type of center. The first one is center of gravity, where the whole mass is being assumed to be lump and act on that point. So that one is the center of gravity. The second one is the roll center, where this is center where your car is being looked from front view roll. Okay. The theoretical point around which the chassis roll and is determined by the design of the suspension. The closer the roll to the center of the gravity, the less the chassis will roll in the corner. The most underutilized adjustment on the car, but one of the most powerful. This is because the roll center has an immediate effect on the car's handling, whereas for anti-roll bars, shock and springs require the car to roll before they produce the effect. So basically, this roll center, based on this one, it's actually the most underutilized adjustment in the car, is because it cannot be adjusted based on the calculation that we did during using MATLAB simulation. It needs to be adjusted in software of multi-body simulation. Like I told you, in multi-body simulation, they not only tune the value for the spring and the shock absorber, they actually tune the suspension geometry and which comprising the hard point. So meaning where they're going to put the mounting for the suspension. Okay, for the strut, the upper point, where is it? So, because that one going to affect the geometry of the suspension, and this one we call the suspension compliance because okay. And then the idea of having this suspension compliance is that they want to have the to create a roll center or roll axis closer to closer to the center of gravity. So basically, when there is a centrifugal force, this centrifugal force going to effect or going to act on the CG. Okay, so let's say that this is your CG, and then this is your roll center. Okay, this is your roll center. Roll center. Usually, this is your when we have a centrifugal force in this direction. So basically, towards the roll center, we're going to have distance d. So basically, this one going to create a moment. So this is actually the one that going to cause your vehicle to roll. So the smaller distance, meaning that you're going to have a small moment that going to try to roll out your car. Okay, and then this distance is actually being determined by the suspension geometry in terms of whenever we use McPherson structure or whenever we're using um, multi-link or SLA type of suspension system. Okay, now this is the how we determine the roll center. So there are many types of suspension system. Which this one, this is actually going to be your experiment. Okay, this is how we determine the roll center for apa for independent suspension. Independent suspension for SLA type because of this one short long arm type, which is we have a short arm, we have longer arm. Okay, and then this where we have the roll center, and usually the okay, usually this is the CG. Okay, so the roll center is over here. Usually this is the distance. Okay, so basically we will try our best to reduce or minimize this one. So if we want to reduce or minimize the shock absorber, the roll distance, the distance between the roll center and the CG. So basically, you just need to reduce tekan kecilkan ini lah, so dia akan kurangkan ni. Kurangkan ini, so kita akan kurangkan this one. Or what we can do is that we're going to lower the CG. So meaning that your because in the end your shock absorber going to hold your chassis, right? So meaning that you need to lower your chassis like typically what with typical modification we go through. You're going to cut your spring, or you're going to use a shorter stroke spring and shock absorber to lower down the CG. Okay, this is the only option. But this one is if you want to lower this arm or this knuckle length, this one you need to do it at early at the beginning of the design phase of the vehicle. But if for normal car, the one that you regard, you would like to reduce the what distance of between the CG and the roll center, so you just need to use a stiffer spring, use a stiffer shock absorber with a shorter length because you want to reduce, you want to pull down the CG position. Okay, any question? This one is just for the SLA type. So later on, this experiment for you to do or draw the type roll center for type of suspension system from rigid, semi-rigid, and independent suspension. So any question for this one? Tak ada. Okay. So how does the roll center work? So if the CG, okay, roll center is far away from CG, where we have lower roll center. when the car corners, the CG has more leverage than the CG, so the car will roll more. Okay, RC closer to CG, higher RC or roll center. So when the car corners the CG has leverage on the road center, so the car will roll less. So kalau if the road center was right on top of the CG, when the car corners, the CG has no leverage on RC, so car will not roll at all. So okay, this one referring to this one. Okay, if the CG far away, so meaning that this is your CG, this is your CG, and then this is your RC. Okay, when the car's corner, so you need to remember the centrifugal force always acting on the the CG. So this one, the car will roll lah. Okay, okay, the car will roll. About this one. So if the CG is uh, RC is closer to CG like this one. Okay, this is the CG, this is the RC. Yeah, shorter. So the car will roll, but it will roll less. Okay, the third one is referring when the RC, okay, RC, and this is your CG. Okay, so when the car will want to roll, it will not roll at all because usually only the if the car will only roll if the CG on the upper side of the upper side on the of the road center. Okay, and then this kind of suspension, the multi-link suspension can create this kind of road center point or position at the upper side of the center of gravity. Okay, so this one the car will not roll. So this one it will roll a lot. So this one it will roll less. So this one it will not roll at all. Okay. Okay, this one is a effect of front roll adjustment center. The front roll adjustment center has most effect on the throttle steering during mid corner and corner exit. So this one is actually referring to the understeer and oversteer driving condition. Okay, so if you take a look at the suspension, that's why you take a look at the for common passenger vehicle, we have only McPherson strap at the front and the torsional being at the back because for McPherson strap at the front, we will have the power to decide the position of our roll center. Usually, and we don't decide the roll center to at the back because of this because of this one because we want our vehicle to have dia punya understeer driving condition because not understeer. Okay, and then for lower front, okay, usually this one we're going to have the either we're going to design the front row center to 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 have a low position of RC, or we want it the front axle to have a higher front row center where this one is going to affect the understeer or oversteer driving condition. So for lower front row center, so we're going to have more on in terms of response. We're going to have more on throttle steering. Car is less responsive, better on smooth hybrid tracks with long fast corner. So kalau kita ada, if we have a higher front row center, so we're going to take a look at less on throttle steering. The car is more responsive and used in a grip condition to avoid traction rolling, and then used on track with quick direction changes. So ini ada dua lah. So again. This one is actually referring to the front row center throttle steering during mid corner and corner exit. Okay. And then the second slide is actually real row center. This one is front. This one is for rear. Effect on in all cornering. Okay. So this one we do the setting on racing car. Okay, for suspension for suspension for suspension tuning we are usually going to tune the camber angle because as you know, okay, if you take a look at this one, okay, if you take a look at this one is actually referring to the camber. So later on, if you want to have this one, we have actually referring to this one and this one. This one is actually camber angle, and usually to achieve the high position of the RC or the low position of RC, other than having the shorter length of the spring or shock absorber, usually the mechanics on the racing track, they're going to adjust for the camber angle, because camber angle, other than increasing the track width of the vehicle, it also affect the position of your roll center, which okay, they want to create this one. They will try to create a less roll during cornering by having apa the distance between the road center and the TG is as small as possible. Okay, because they want this to have this kind of characteristic. Okay, if the road center has a higher road center, they're going to have this kind of characteristic. If it has a lower or front road center, it's going to have this kind of characteristic. Same goes for the rear. Okay, and then usually for rear, we only tune for the racing car, not for passenger vehicle. Okay, so this is the characteristic if you do the tuning for the road center. Okay, now this is the roll bar, anti-roll bar. So anti-roll bar is actually the one other element that is going to assist your vehicle from or preventing it from rolling out. So other than the roll center, so we have another element to reduce the rollout, which is we have the anti-roll bar. So usually in anti-roll bar, so this is the main element. So we have the anti-roll bar link. So this one usually we call this one as a drop link. So okay, if you familiar this one, saya akan buka yang dekat kereta lah. Hold on, so give you actual picture. Because anti-roll bar plays a huge effect in your preventing your car from rolling out, and also provide high stability at corner and very high speed. Okay. Anti-roll bar. Anti-roll bar or stabilizer bar, or some call it as a sway bar. Hmm, wait, I'm finding, still looking on the perfect what actual car vehicle with the anti-roll bar, so that you can imagine how it works. Belakang. Okay, so basically this is your stabilizer bar. So if you are if any car will have what this stabilizer bar. It depends how simple it is. Okay, like for example for the stabilizer bar, sway bar or apa anti roll bar in produk kancil, it's too simple. But yeah, it's too simple, but even though it still provide apa, or assist in providing less roll during corner, but that role, what the role prevent action is not sufficient. Okay, it's actually insufficient compared to the one that we have in, for example, in Proton car, because in Proton car it's been designed properly. Okay, the main element in stabilizer bar is this one, the drop link, and then this anti roll bar. Okay, the drop link is basically okay, this one. If you take a look at these two ring over here, this one is actually the attachment point to the chassis. So meaning that this one will be this one. Okay, this one is actually being attached to the chassis, and then this roll bar will go through it. So it's as if the chassis will hold this roll bar. So what happens is that whenever there's a roll motion, so this is front view. Okay, this is front view. So let's say your car is moving to left to this direction. Okay, and then so basically your chassis going to roll out in that direction. Okay, okay, this is okay. So this one is front direction. So when your car is moving towards this direction, so you're going to have a roll moment. You're going to roll out. So to create this moment, so meaning that this one going to there's a force over here, and then there is also force over here to create this moment, this counterclockwise direction. And then since that this apa your chassis being attached to the roll bar using this connection link. Okay, so basically it will pull up this side of the anti roll bar upward. Okay, and then when this one going up, it's actually going to push down action reaction. So this one, this Newton apa Newton law. So basically, you can push down this arm, lower arm. So meaning that whenever your car is rolling out, your wheel is going to be pushed down in the other side, this one. So preventing this one to have it will prevent the car from having excessive roll. So it will roll, but your car will not topple. Takkan terbalik lah. So ini akan tekan ke bawah. So ini akan biasalah dia punya load transfer akan tekan kat sini. Sini tak ada there won't be any excessive load over here. Okay. So it's going to go up, this one going to go down. So this one is going to go up to action direction, but this one still in contact because we still have the load over here, the load transfer. This one, the contact on this side of tire will be assisted by the load transfer at the sway bar, and then the tire at this side will be pushed down by the load transfer. Okay, load transfer still exists. Okay, so that's how we reduce the roll effect during corner and how the anti-roll bar did it. Okay, sama lah yang kat sini. Okay, this is the drop link. So ini the attachment point lah dekat untuk for your anti-roll bar. This one. Same thing. So any questions for this anti-roll bar? So basically, if you use a standard anti-roll bar by manufacturer, usually it's going to work well at the beginning of the car lah, and then eventually over time, the performance going to be reduced because of this bushing. Okay, if you take a look at this one, this is actually a bushing. rubber bushing. So this one going to harden, and then going to crack, and then going to damage. And then when it damage, it's going to create the gap or small gap. It's going the holding of the sway bar or stabilizer bar or anti-roll bar. It will not hold this bar firmly. So that's why you see over time your car, the anti-roll performance is not as good as when you first bought it, because of this one. If you want to change or improve the roll bar as uh, like uh, like the one like a new one, so you need to change this one, and also you need to change this drop link. So same thing. The problem is over here, the rubber or bushing over here. So it's going to damage over time, going to harden and crack. Okay, and then it's going to affect your roll performance of your car. Okay, so any question on this one? Any question? Okay, good. If there's no question. Okay, now for the assignment, I want you to determine the roll center for rigid, semi-rigid, and independent suspension. So, okay, and then describe how the roll center for these suspension can be drawn and determined. So, for example, we have three types of suspension: the rigid, semi-rigid, and independent. I want you to pick one of pick one suspension for rigid type, and then another one for semi-rigid type, and another one for independent suspension type. I want you to draw the roll center for each type of this suspension, and then with the instructions on how to draw that one. Okay. Okay, understand on this assignment? Faham tak? Okay. Okay, and then I want the due for this assignment submission is that the due is 1 week from now. So I'm going to give you about a week. So on today Saturday next week, so 15. So I want you to submit on 16 January. Okay. 16, okay, 16 January 2022. By 5 p.m. Okay. The submission. I will provide this one later on. Okay. No. Better, I'm going to do this. The submission for the assignment is going to be via e-learning link. Okay. So any questions on the assignment? So yeah, the submission is another in a week time. So I'm going to enable the submission link in the e-learning. Okay. So because for this semester most of it we don't use e-learning, but I'm trying to make use of it. So we're going to use it for the for the assignment submission.
Can we make it 12 a.m.?
Pardon?
12 a.m. The due.
I cannot hear your voice. What do you mean?
I mean the submission time. You said 5 p.m. right?
Yes.
So I said the 12 p.m. Is it possible?
No, because you're supposed to submit on Saturday, but this one already give you another one extended day. You submit on Sunday. So by Sunday is actually working day. So I'm going to submit by 5 p.m.
All right.
Okay. Okay. Any other question? Okay. If there is no other question, so we can dismiss. Okay. Assalamualaikum and thank you. See you in our next week class. So basically, I'm going to try to finish these topics as soon as possible. because of two reasons. Yeah, you can focus on your project, and then also you can focus more on your assignment. And then I think, yeah, because right now I actually, maybe possibly in near time I'm going to have an emergency leave because, yeah, right now I'm expecting what, a baby. So when my wife deliver my baby, basically I'm going to, apa, to take leave. Okay, so emergency leave for take care of my wife. So I think in another, 3 weeks, in 4 weeks. So when I did that, so meaning that, yeah, kita kena cancel class lah. So to prevent that, so I'm try to finish all the topics as soon as possible, and then answer all of your questions. And then once we done with that, so we can focus on your project and also study for your final exam. So like I told you, the okay, for test and final exam, it's just that it will be on, whatever I deliver during our class. Okay, you don't have to study more, just study whatever, apa yang saya bagi lah. Okay, and then for test too, I haven't decided. So I'm going to I'm going to tell you during, next week class on apa, possibly on Monday or Tuesday. Okay. So kalau tak ada apa-apa, so we can dismiss. Assalamualaikum and thank you.
Thank you, Doctor.